Hi everyone, in lesson 3 we're going to be looking at graphing and writing the sine function. The sine function y equals the sine of theta matches the measure theta of an angle in standard position with the y coordinate of a point on the unit circle. Remember, when we're looking at coordinates on the unit circle, we said it's x comma y cosine comma sine, x comma y cosine comma sine. So if we were to graph the sine function, we'd be looking at the y part of the coordinate. So let's write in what the angles are here. We start at 0, and we go to 90 degrees, but I'm going to write these in radians, so I'm going to write pi over 2. Then we go to 180 degrees, or pi in radians, 270 degrees, or 3 pi over 2 in radians, and then back to 360 degrees, or 2 pi in radians. So we're going to sketch the sine function, and again, we are looking at the y part of the coordinate, what I have highlighted in blue. So the sine function is a 5-point pattern starting at 0. So we start here, and then we do 4 more tick marks to draw one cycle of y equals sine of theta. And if we look at those values, let's just look at them. We've got a value of 0, 1, 0, -1, and 0. The values go up and down between 1 and -1. We start at 0, we go to pi over 2, we go to pi, we go to 3 pi over 2, and then we go to 2 pi. What I like to do when I sketch a curve, I usually do a dashed line to show that that's going to be the max of my curve to give me a little guideline, and I'll do the minimum. I'll do a dashed line at the minimum as a guideline for that. So let's take a look at what we have here. At 0, at the angle 0, the sine is 0. So we have a point at 0. At pi over 2, the sine is 1. Pi over 2, the sine is 1. At pi, the sine is 0. At 3 pi over 2, the sine is -1. And at 2 pi, the sine is 0. And now we can sketch that. So we've sketched one cycle of y equals sine theta. And just keep in mind that this will continue indefinitely to the left, and it'll continue indefinitely to the right. Right? We just sketched one cycle. Now we're going to use that graph to answer some questions here. What is the value of theta equals pi over 2 for y equals sine theta? So if we look at our sketch here, when we look at pi over 2, what do we get? We have a value of 1. If we look at theta equals 3 pi over 2, we have a value of -1. For what value of theta between 0 and 2 pi does the graph equal 0? So where do we have zeros on this graph? We have zeros at 0, pi, and 2 pi. A periodic function is a function that repeats its values at regular intervals. Is the sine function periodic? Yes. Like I said, we're going to continually repeat this pattern to the right, and it also repeats to the left. Here we have properties of sine functions. So we're looking at y equals a sine b theta, where a does not equal 0, b is greater than 0, and we're talking about theta in radians. We usually refer to the angles on the unit circle in radians. The absolute value of a is the amplitude of the function. That's going to tell us the distance from the center. If a is less than 0, in other words, if there's a negative in front of a, it's going to mean a reflection over the x-axis. B is the number of cycles in the interval from 0 to 2 pi, and 2 pi over b is the period of the function, the length of one complete cycle. So that probably seems a little bit confusing, so we're going to go through lots of examples so you can understand, what we mean by all these new terms, amplitude, cycles, period, and so on. So number 1 says, using the parent function y equals sine theta, we're going to just determine some things here. First one being, what's the amplitude? Well, the amplitude is the value that is in front of sine. So there's an invisible 1 here. So the amplitude of the parent function of sine is equal to 1. That means the distance from the center is 1. So if we go back and we look at our graph, right, the distance from the center is 1. Here's our center, right on the x-axis. And the distance from the center is 1. Our amplitude is 1. Find the period in radians, all right? So the period is 2 pi over b. B is the value that's going to be in front of theta. So here, the value that's in front is 1. So our period is 2 pi over 1, which is just 2 pi. So where does our cycle begin to repeat? Again, let's go back and look at this graph. So it begins to repeat right at 2 pi. The period, one complete cycle, happens from 0 to 2 pi, and then we start to repeat after 2 pi. And then enter the domain and range. So the domain is all the possible x values. Let's go back to the graph. Are there any values left or right that are not going to be included? We know we go indefinitely to the right and we go indefinitely to the left. So there's no x values that are not included in this parent function, y equals sine theta. So the domain is all real numbers. The range is all the possible y values. So this graph goes between -1 and 1. So the possible y values are between -1 and 1, including -1 and 1. Number 2 says, for the function y equals sine 4 theta, determine the number of cycles in the period. All right, well, the number of cycles is going to be b, and this curve is in the form y equals a sine b theta. So we can see that b is 4, so the number of cycles, the value of b is equal to 4. And then to find the period, we're going to do 2 pi over b. So we have 2 pi over 4, or we could just simplify that by writing in pi over 2. The graph of a sine function is also called a sine curve. By varying the period, you get different sine curves. Find the period of each sine curve below. The x-axis shows values from 0 to 2 pi. So we're saying that this ends at 2 pi. And this one is 2 pi. So we want to know the period. Well, we have one cycle from 0 to 2 pi, so b is equal to 1. So the period then is just going to be 2 pi over b. But for this guy, it's 2 pi over 1, so the period is 2 pi. For b, this time, for the value of b, we have, well, let's see, we have how many cycles to between 0 and 2 pi? We have 1, 2, 3. So the value of b for letter b is 3. That means our period, 2 pi over b, is going to be 2 pi over 3. Right? The amplitude of a sine curve can also be varied. On the graphs below, each x-axis shows values from 0 to 2 pi. So we're ending here at 2 pi. Find the amplitude of each sine curve. What does this tell you about the amplitude? right? The amplitude of y equals sine theta. So let's just look at that graph again. Here's y equals the sine of theta, or y equals sine x, same thing. It's going up 1 and down 1. The distance from the center of this graph is going to be 1. Now, if we look at y equals 2 sine theta, we can write theta as x, or we can write it as theta. You can see that the distance from the center of this graph is 2. So that amplitude, that value in front of sine, is telling me the distance from the center. So this is 2. What's the amplitude of y equals negative sine theta? All right, well, if we have a negative in front, that means we've reflected the curve over the x-axis. So here we have it reflecting over the x-axis. And we have our center right on the x-axis, and we're going up 1 and down 1. So even though we've reflected it over the x-axis, we haven't changed the amplitude. The amplitude is still 1. The distance from the center is still 1. And then the last one is, what's the amplitude of negative 2 sine theta? So here's negative 2 sine theta. What's the distance from the center? Here's the center. We go up 2 and we go down 2. So the amplitude of that is 2. Since amplitude always represents the distance from the center, and I can't say that enough, I'm repeating it a lot because it's a really important concept, the amplitude is always positive. How does a negative in front of A affect the position of the curve? Well, the negative means that it's going to reflect over the x-axis. For each of the following, find the amplitude and the period in radians of each function. All right, so we have y equals sine theta. And you might want to make a note here that this function is in the form of y equals a sine b theta. A represents the amplitude and B represents the number of cycles. So for letter A, the amplitude is equal to 1, and the period, which is going to be 2 pi over B. B is 1, so it's 2 pi over 1, or 2 pi. For letter B, the value of A is 3, and the period is going to be 2 pi over B. B is 5, so the period is 2 pi over 5. For letter C, the amplitude is 2. Now be careful. This is where you could, trip up a little bit. The amplitude is just 2. Don't write negative 2. Amplitude is distance from the center. It's always positive. That negative is going to tell me I reflect over the x-axis, but it doesn't, have anything to do with amplitude or the distance from the center. So for letter C, amplitude is equal to 2, and the period is going to be equal to 2 pi over B. In this case, B is pi, so the period is equal to 2. So for letter C, amplitude is 2, and the period is 2. All right. Letter D, amplitude is equal to 5. The distance from the center is 5. And the period's going to be 2 pi over B. So 2 pi over B. Now, B is the value in front of theta, so we've got 2 pi in front of theta, so B is 2 pi. So 2 pi divided by 2 pi is 1. So the period for letter D is 1. Amplitude is 5. Graphing and writing sine functions. You can use 5 points equally spaced through one cycle to sketch a sine curve. For a greater than 0, the 5-point pattern is 0, max, 0, min, 0. When a is less than 0, the 5-point pattern is 0, min, 0, max, 0. So we have our parent function of our sine curve, 0 max, 0 min, 0. And if we reflect it over the x-axis, we have 0 min, 0 max, 0. Number 1, sketch one cycle of the sine curve with an amplitude of 3, a period of 4 pi, and a is greater than 0. Okay, our amplitude is 3. So we know that our distance from the center is 3. So we're going to go up 3, and we're going to go down 3. And I'm going to mark this with some dashed lines just so I know where my max and my min are for my graph. My center is right on the x-axis at 0. My period is 4 pi. My pattern has a 5-point pattern starting at 0. So 1, 2, 3, 4, 5, and my period ends at 4 pi. I know that a is greater than 0, so I know that my pattern is 0, max, 0, min, 0. So let's plot those points. 0, max, 0, min, 0. And I think you may want to put some arrows on the end just to show that you know that this graph goes indefinitely to the left and to the right. Now it says write the equation. So the equation should be in the form of y equals a sine b theta. And we know that our period is 4 pi, which is 2 pi over b is equal to 4 pi. So we have to solve for b. So we have a fraction equals 4 pi. And I'm just going to write 4 pi over 1. And now I can cross multiply and solve for b. So 2 pi times 1 is 2 pi. And 4 pi times b, when I cross multiply, 4 pi times b gives me 4 pi b. Solve for b. That means I have to divide both sides by 4 pi. So what happens? We end up canceling, right? And we get 2/4 equal b, or 1/2 is equal to b. So b is equal to 1/2. A little bit of work to find b in this case. And we know that the value of a is the amplitude, which is 3. So let's make a note that a is equal to 3 because the value that they told us for amplitude is equal to 3. Okay, we're all ready to write our equation. So y equals 3 sine 1/2 theta. Write theta or x, whatever makes you happy. All right, I would suggest trying number 2 on your own and come back when you're ready. For number 2, we know that the amplitude is 2. So we know we're going to go up 2, and we're going to go down 2, and that's going to be the max of our graph and the minimum of our graph. The period ends at 2 pi over 3, and we have a 5-point pattern. So 1, 2, 3, 4, 5, ending at 2 pi over 3. And we know that a is less than 0, so our pattern is going to go 0, min, 0, max, 0. And then we'll connect the dots, put arrows on the end. And now we've sketched one cycle of the curve with those criteria. Now we're going to write the equation. The equation should be in the form of y equals a sine b theta. We need to find b. We know that our period is equal to 2 pi over b, and we know in this case our period is 2 pi over 3. So we have to cross multiply and solve for b. So 3 times 2 pi gives me 6 pi, and 2 pi times b just gives me 2 pi b. Divide both sides by 2 pi. So on the left side, we end up with 3. On the right side, we have b, so we know b equals 3. And we were given the value of a is equal to 2. So our equation then is going to be y equals, now be careful, we said that a is less than 0. We had to reflect this curve over the x-axis. So we have a negative in front, then we have 2, the sine, the value for b is 3, and just for fun, I'm going to use x this time. All right, that's everything I have for this lesson. We're going to do more of the same with the cosine curve, vary the pattern just a little bit, but it's going to be the same idea. So hope you enjoyed it. Have a great day.